Now, sending the sound out, it's very much like a megaphone. Now, the megaphone in this example is not so much an amplification device, but rather a focused directional control of the sound waves device. In other words, if you cup your hands together like this, watch what's going to happen with this microphone here. I'm going to cup my hands together, and it's going to appear to get a little bit louder because all those sound waves are then focused forward. And that's what a megaphone does. It focuses your voice. So check this out. Testing 1, 2, 3. Testing 1, 2, 3. It got noticeably less loud because I was pointing the sound waves away from this microphone. Same thing goes when you're pointing your speakers at your audience. Now, in a future class, we are going to cover layouts and how to cover your complete audience depending on what kind of microphones you have. And each speaker has a certain directionality to it that we're going to read from the speaker dispersion charts. For now, this microphone is pointed at whatever angle this seems to be. Now, speakers. Speakers are much like megaphones and your vocal cords working together. The diaphragm of the speaker resonates back and forth and pushes air. It pushes the air forward and or back. That's what creates a sound wave, because that wave goes front and back and forth, back and forth, back and forth. The shape of the cone resembles a megaphone in that it gives some directionality. And some speakers are extremely directional because of the way that the rest of the box is built, and some can be heard from just about anywhere. The lower tones are heard anywhere for the most part, and the higher tones are much more directional. I don't know if you have a stereo system at home, like a 5.1 for your sound system for your TV or whatnot, but that 0.1 is the subwoofer that sits in the corner, but you can hear it everywhere. Whereas the other speakers are more directional, and you point them to where you're sitting. And hopefully you point them at your seat so you get the best sounding experience. Now, this microphone here, this speaker here is probably, a lower range because it's got a big diaphragm, and it pushes the air out. Now, inside this box, there may be cones shaped like, cones shaped like megaphones, or, the case of the box can be shaped like a megaphone and direct the sound in one direction. That's the basics of this speaker. Let's talk about how to power them. Now, the difference between these two speakers, other than their cabinet style, is not evident at first glance. The one on the left is called a passive or non-powered speaker, and this requires an external amplifier. The one on the right is referred to as a powered speaker, as there is an amplifier built in. How do we tell? Let's look at the back panels. So this one here for the unpowered one has two ports, two inlets for connectors. Now these happen to be special connectors for speakers, and various different speakers might have different connectors, so yours may look different. But you'll notice it just has these two ports. Some of them will just have one port. This panel over here on the right, however, has a port for a power cord, and it has control lines. This we see that will have two microphone ins. It's sort of like a mini mixer. Let's take a closer look at that. So here we have a microphone, channel 1, and actually this is both a microphone port and an instrument or line level port. This will accept an XLR cable, or it'll accept a 1/4 inch cable right there in the center. Okay, so the XLR cable has the 3 dots or the 3 pins. So there's 1, 2, 3. Just like here, 3 pins, XLR. And the 1/4 inch one just has, you just stick it straight in. Here we have a gain control, and you'll see that this one's pointed a little bit more off to the line area, right, for line level. There's also mic level over here. This one's pointed more towards mic level. So line level, it has more power, so it needs less gain. Mic level has less power, so it needs more gain. Again, gain is the sensitivity of how much it's going to allow to suck in from the microphone. And then we have this main control over here. Here we have an infinity mark. Now infinity means full resistance, which means nothing comes through. It stops completely. Infinity resistance. Maximum means it's allowing the maximum power to go through. And lest you think this knob controls this output, it actually doesn't. It does, but it also controls these two outputs over here. So this goes out of here through the main, then out the front of the speaker. So you need to make sure that that's turned up when you're doing that. There are some modes that can be used in the speaker. Your mileage may vary depending on the microphone, on the speaker that you have. These happen to be Mackie from a choir that I was able to take these pictures from. Powered speakers come in handy for a lot of school functions. You can walk into a room with a speaker and a microphone and a cable and be powered up in no time because you just plug it into the wall. Now, with that said, we do need to have some caution though, because on the back of this, we'll notice that it has a model. It's called the Thump 15A. Now, the 15A stands for amps. It tells us what kind of circuit we can plug it into in the wall. Here it says 1300 watts. So if it says 1300 watt loudspeaker, and it's got 15A right in the name, we need to plug it into 15 amp circuits into your classroom or other venue power. It also means that if you plug two of them in, you may blow the circuit or the circuit breaker. So you've got to be cautious about that. We don't want to be blowing our circuit breakers, but if you have two of these and you drive them to some degree of loudness, as these get louder, they take more power. So if it's very low, you probably won't have a problem. But if you get loud, it may draw enough current out of the wall that it's going to trip the circuit breaker. So you need to check out the circuits in your classroom or other venue to make sure that you're not going to run into that trouble.